Most beginners think programming look like this. Open laptop, write code, and run it, and it's done. But real programming, it doesn't start with a code. It starts with a problem. And this is exactly where most beginners make their first mistake. They start typing before they start thinking. And trust me, that becomes expensive later. Today, before we write our first real CPP program, we need to understand how CPP development actually works. Because if you understand the development pipeline, learning CPP becomes much easier. A simplified CPP development pipeline look like this. Step 1, define the problem. Step 2, design a solution. Step 3, write the program. Step 4, compile it. Step 5, link object files. Step 6, testing. Step 7, and debugging. In this video, we will focus on the first two steps, and surprisingly, these two steps have nothing to do with syntax. Step 1, define the problem. This is the what step. This is the what step. You ask yourself, what problem am I trying to solve? Simple question, but extremely important. Sometimes coming up with an idea is easy. Sometimes it's the hardest part. But conceptually, this is the simplest step. All you need is a clearly defined problem. Let me give you an example. You might say, I want to write a program that allows me to enter many numbers and calculate their average. Or maybe I want to build a 2D maze game where the user wins after reaching the end. Or even something advanced like I want to build a program that reads stock prices data and predict whether stock will go up or down. Notice something. Each problem is specific. Bad problem statement, I want to make something cool. Good problem statement look like this. I want a program that takes input X and produce output Y. Specific problem create better solution. Now comes the step most beginners skip. And honestly, even many experienced developers mess this up. Step 2. Determine how you are going to solve the problem. This is the how step. You already know the problem. Now ask, how am I going to solve it? And this is one of the most neglected steps in this software development. Why? Because there are many ways to solve the same problem. Some solutions are good, some are terrible. But beginners usually do this. Idea comes, open editor, start coding. No planning, no designing, just wipe. And that usually creates a bad software. So what makes a good solution? According to LearnCpp, a good solution has 4 major characteristics. First, it should be straightforward. Your solution should not be unnecessarily complicated, and complicated system create confusion, and confused programmers create bugs. Simple doesn't mean weak. Simple often means better. No? And second is it should be well documented. You should clearly document assumptions, limitations, design decisions, because after 3 months even you may forget why you wrote something, and if someone else reads your code, documentation becomes gold. And third is it should be modular. Modular means dividing the program into smaller reusable parts. Think like Lego block. You can replace one block without destroying whole structure. That makes future update much easier. Fourth is it should be robust. Robust system handle unexpected situation gracefully. Example, what if user enters text instead of a number? Bad program crashes. Good program show useful errors, message, and recover that robustness. Here's the truth. Most beginners don't want to hear. Programming is not mostly typing. Programming is mostly a problem solving. The keyboard is just a tool. Your brain does the real work. Now let's talk about something every problem will meet. Bugs. If you start coding immediately, you often choose the fastest possible solution. And fast solution can become fragile, hard to extend, hard to maintain, and full of bugs. You understand? But what exactly is a bug? A bug is any programming error that prevents the program from operating correctly. Simple. If software behaves incorrectly, there's a bug somewhere. But why do we call it bug? There is a fun story. Let's talk about this. The word bug was first used by Thomas Edison back in 1870s, but the term became famous in the 1940s. Why? Because engineers found an actual moth stuck inside an early computer. Yes, a real insect inside hardware. That moth caused a short circuit, and ever since then, the word bug became legendary in computing. Imagine debugging for hours and the bug is literally a bug. 1940s programmers suffered differently. Now here's something that shocked me when I first learned it. Studies on complex software systems shows programmers spend only about 10 to 40% of their time writing the initial program. Let that sink in. Only 10 to 40%. So what happens during the other 90 to 60% is maintenance. And maintenance includes 4 major things: debugging, finding and removing bugs, updates, adapting software to new environment. Example, new OS version released, now your software breaks, you update it. Enhancement, small improvement to usability or features. Example, adding dark mode. Internal improvement, improvement reliability or maintainability. Even if users don't notice changes, engineers may improve internal code quality. This changes how you should think about programming. If most time is spent maintaining software, then rushing into coding is dangerous, very dangerous, because messy code today becomes suffering tomorrow. That's why spending extra time before coding is worth it. Think about best approach, assumptions, future changes, possible edge cases. That upfront thinking can save you hundreds of hours later. Bad programmers ask, how fast can I code this? Good programmers ask, how well will this survive future changes? So what did we learn today? Before writing CPP code, first define the problem, then design the solution carefully. That's the real beginning of programming. Not syntax, not semicolons, not compilers here. Thinking, planning, problem solving. Done. That is the where programming starts. In the next video, we will finally move to step 3, writing actually CPP source code. We will talk about code editor, source files, syntax highlighting, why file names like main CPP matter. So if you are serious about mastering CPP from beginner to advanced, just follow me. I think you should follow more LearnCpp.com website and then me. And comment below, what do you think is harder, writing code or designing solution?